Hello and welcome to the CNN News 18 special broadcast. ISRO is all geared up for Chandrayaan-3, and over the last nearly 4 years, a dedicated team has worked hard, taking a lot of learnings from Chandrayaan-2 and ensuring that they're all prepared for Chandrayaan-3. Well, they're excited, they're also conscious, a lot of lessons learned. So how has this journey been? What are the lessons learned? Who better than former ISRO chairman, Mr. K Sivan, who's joining us today, sir. Welcome to the show.
Thank you.
Sir, September 2019, it almost broke the hearts of the entire nation. We saw the lander crashing. After that, ISRO got back. How's the journey been, sir, over the last nearly 4 years or so for this entire team at ISRO?
Basically, this last 4 years, the tremendous work have been done. And the first and foremost one was that in the Chandrayaan-2 landing phase, it was not successful, whereas orbiter mission part is successful.
Yes.
The lander portion was not successful. And from the data what we gathered during that time, that data was analyzed very thoroughly, understood what really went wrong. And now for each problem what we observed, now the corrective actions have been taken. So, and also not only that one, some wherever the margins are less, so the robustness level was increased, so that now we are going ahead. Last 4 years, these works are done very thoroughly, meticulously. And then the tests have been done very exhaustively and ensure that everything is intact. With this confident, now the ISRO is going for the next mission, Chandrayaan-3.
Sir, ISRO has spent a lot of time looking at what went wrong with Chandrayaan-2. What went wrong, sir, according to you? Things that you could explain to the common man.
Basically, that there are some few things, not only one problem, some few things were there in that one. One was this, the propulsion system was, the dispersions in the propulsion system in certain region of the flight was more than what we expected. That means, in that the total landing phase, we had that 4 phases. One is a rough braking phase where the maximum velocity has to come down.
Yes.
Then that the attitude hold phase, then fine braking phase, then landing phase. Like that 4 phases are there. In the rough braking phase, this the propulsion system worked very nicely without any problem. In the attitude hold phase, yes, that time also propulsion system worked very nicely, but the dispersions level, it was sometime more than what we assumed before flight. This was one problem. And because of these dispersions levels were more than expected, the guidance software was not able to handle it properly. So it was misbehaving. Instead of correcting it, instead of reducing the thrust level, it is increased the thrust level. So guidance software misbehaved.
Okay.
Along with the guidance software misbehavior, this control system also there was a limitation. It's not control system not misbehaved. It is there is a limitation of limiting certain parameters. Less if it is exceeding certain value, we are clamping the value to a certain level. So that clamping also was less. If all these 3 things combinedly made this landing is a hard landing. If any one was, the issue was not there, the mission would have been success. So there are 3 multiple problems occurred simultaneously in that mission. So that way, that particular mission was, we understood that total data and analyzed the data and understood the problem. Now corrective actions have been taken considering all these issues.
So corrective actions have been taken. Any changes to either the rover or the lander, sir, apart from correcting these mistakes that you said that were there?
Yes. That is definitely there are some change improvements were made. That is one is that one is made corrections to overcome the problem what we have seen.
Yes.
Second one is not only that one, it added more redundancies,
Okay.
sensor redundancies. That is suppose in one system is failing, that is so that the data will be taken from other system. This redundancy have been increased. That is one thing. And another one is that is it is the allowable dispersion level is enhanced. Then that lander,
Yes.
that leg design have been modified to withstand higher landing velocity also.
So you're saying if in case the lander lands with a bigger speed, higher speed, it can still withstand the legs of the lander. If I understand.
Higher speed, it is not like very large speed.
Yes.
Like earlier, it was like up to 2 meters per second velocity it can land. Now 2 hours per 3.
Okay.
Okay, not
Yes.
not a very large.
But you have a bit of a cushion there.
Some extra margins have been built in within our allowable limit, within the capacity allowable the limit. With this corrective actions have been, or the robustness margins have been increased. This one.
So for the whole team, how different will this Chandrayaan-3 be, sir?
Now, actually, when we went ahead with the Chandrayaan-2, also there is that people that we had a confidence that it will be going without any problem, because the space scientists will always go ahead the mission after ensuring that whatever that problem they encountered, it is getting corrected, and with that confidence only will go through.
Yes.
In the Chandrayaan-2 also we went through like that only. But usually the space system, the space is hard.
Yes.
Always that in the first mission, we always learn something not came out in the ground. It will happen only in the flight. That we used to call unknown unknowns. So this type of thing it used to come in the first mission. So in the unfortunately for us, it is end up with a mission failure.
Yes.
And but we have learned a lot of things. So at that time also we have, before going we have full confidence, but we have end up with the failure. But we have learned a lot of new things into in the process. So all these new things, now we have been working last 4 years, and now it has corrected. With this correction, now also we have a full confidence that this time it will be success, because we know that all the issues whatever we faced is corrected. Also additional margins have been increased.
Yes.
Margins, redundancies, that type of things are increased, so that our level of confidence is this time also more.
So you spoke about working hard over it for the last 4 years. How easy or difficult was it to motivate the team, sir? We saw the Prime Minister there that day. You got emotional. After that, you got back to work. What were the challenges, sir, according to you?
The main challenges was that to analyze the data, go through the data, and find out that the exact cause. That's a real challenge. Yes, we used to get a huge amount of data for a flight. This one, and each bit of data was analyzed, and to understand what really went wrong, and find out, so that we don't want miss this time.
Yes.
So every aspect was looked into very carefully, so that no stone is unturned.
Yes.
So everything is now looked into clearly, and that analyzing and understanding the whole problem, and also they recreated the problem in the lab level. These things were really the complex process, and after that one, that is that now that we have included that the correct action, And not only corrective actions, additional sensors also have been included. Additionally, that is the extra improve that the margins also have been improved. Improved to get a better confidence at this level.
Sir, it's in the final stretches now, final leg. How's the mood, sir, within ISRO, especially this team?
Now, this team really they are very happy. This time that that we will have a confidence level is more. It is not that like during when we are gone ahead with the Chandrayaan-2 level, Chandrayaan-2 mission confidence level is less. No. We will not go when the confidence level is less. Only when we are satisfied only we go.
Yes.
And now, because we have gone through the entire data, and we have got little bit more than that also, and we have corrected the system error or the possible error. In addition, not only leaving to there, now we have given the system for working in the wider operating regime. That way, a lot of redundancy is incorporated.
Yeah.
So failure modes also handling. In case of that one is also now is a more and more failure modes you can handle. All these things are given share. So definitely, they are now people are happy that we have addressed all the issues, and so they are very happy that this time it will be success.
Absolutely. Sir, just put this in context to us. Yes, India can showcase that it can attempt and successfully carry out a soft landing, operate a rover on the surface of the moon. How important is this mission in the larger scheme of things for Indian space program, sir?
See, first of all, by that demonstrating this one, the India has acquired one more technology of landing in a foreign body.
Yes.
Or in a celestial body, not foreign body, celestial body. We are able to land. That is, this technology we have gained, we have acquired. This is the big lessons we have. So it will have a future perspective of landing, sometimes man landing on the moon. Like that, many such human presence in space, and that it will be giving very good information. The technology it will give. That is the one point. Second point is scientific the measurements. That is science part.
Yes.
And by doing this one, even though we are doing the science about the moon by observing from a particular orbit, and we are doing now by landing we can do the in situ experiments, the science, in situ science.
Yes.
That more science we will get it by having such type of missions about the moon for the future generations.
True. So, obviously Chandrayaan-3 is the focus now. But I want to ask you about two other important projects of ISRO, sir. One is Gaganyaan. That's also under works right now. What can we expect on that front, sir? A lot of work happened during your tenure also.
The Gaganyaan mission is mainly for launching that astronauts to that 400-kilometer orbit and bring the astronauts safely back to the Earth. That was the purpose of the Gaganyaan program. In that one, that is many new technologies again we need to develop. First of all, we wanted to ensure that the vehicle wherein they are traveling, the launch vehicle, that should be having that human rated level, reliability level point of view.
Yes.
Which otherwise we are able to launch only the spacecrafts.
Yeah.
Now human we are launching, so definitely that is it should be reliability level is be higher.
Higher, yes.
So it will be human rated. So that is one technology. Another one is we need the technology where that we need to create the environment which is conducive for the people to survive.
Yes.
that is the crew module, and the environment control life support system, that is another system. And also when we are launching them, in case of emergency,
Yes.
and we ensure that these astronauts are brought back safely, escape from the system and brought back safely to the Earth.
Yes.
Then the fourth one is, that is after mission is over, this the astronauts should be brought down and ensuring that they are passing through the very adverse environment of heavy heating and land at the exact location. So here the huge number of new technology development it is required. That is definitely that is for last 5 years, nearly 5 years. This is a huge amount of work have been carried out, and now that the project is in the testing phase, where that we need to do lot of tests.
Yes.
With the system, and once that is tests are completed, then we will be going for the mission, Gaganyaan mission.
So
Sir, 1 minute. Close that to sir.
yeah.
Yeah, okay. Okay. It's very complicated. You can-
Okay. Yeah. So the other ambitious project of ISRO is its partnership with NASA, the NISAR mission. How important is that, sir? Because probably one of the most costliest projects that we have seen in the recent times. Also has immense value in terms of how India monitors the impact of climate change in certain regions like the Himalayan region. How important is it for the country and ISRO?
Actually, this particular program is an excellent collaborative program between NASA, ISRO for making a combined satellite, NISR, NASA, ISRO synthetic aperture radar satellite. So here is some part of the payload is from our side, and the main part of the payload is from the NASA. So it will be made as a spacecraft in ISRO. It is made as a spacecraft, and then it will be launched by ISRO. This is the program. It's a very very interesting collaborative project. And this particular satellite instruments are so costly. So as per till now, this is the costliest Earth observation satellite built so far.
Across the globe, sir?
Across the globe.
Okay.
It is the costliest Earth observation satellite, not the all satellite, Earth
Yes.
observation satellite. And this particular satellite, the specific feature is it could be able to identify something like 1 centimeter movement on the surface of Earth from the height of around 700 kilometer. And because of this particular nature of the payload residing in the spacecraft, it will be giving so much information about the climate change and the earthquake and the glacier melting. This type of information will be known to it will be available much before the event is happening. So that it can be predicted using the information, and so that corrective action can be taken. So this satellite it is not only going to give the information to US or India. Definitely, once it is put in the service, the satellite is going to play a global level data, which is so important for the humanity, and that way this project is very, very important for our for both NASA as well as ISRO or India.
True. Well, sir, it's a eventful year for ISRO, and we really hope it gets off to a very good start with Chandrayaan-3. Thanks a lot for talking to us, sir.
Thank you. Thank you.
Well, that's it in this special broadcast. We'll keep getting you more such insightful interviews and interesting stories about Chandrayaan-3. Keep watching CNN News 18.